Sarah Holkett. On here you'll see my screen. So for this project I chose case number 2 along with case number 4. These both had to do with glycogen, which is interesting. They both kind of related. But anyhow, the first question read, a 16-year-old female is recently diagnosed with a deficiency of muscle glycogen phosphorylase. She and her family are concerned and ask the following questions. Based on what you know about skeletal muscle glycogenolysis and muscle metabolism, please respond to each question with a thoughtful answer that describes the metabolism in these various scenarios in language that your patient will understand. So the first question that I asked, I'm not sure I understand the issue. Can you explain how muscle glycogen is used normally during exercise? So in a typical adult or child, anybody, typically healthy human during exercise, muscle glycogen is broken down, and once it breaks down, it releases glucose or oxidizes glucose. And this happens during anaerobic and aerobic exercises. So essentially, aerobic exercise requires oxygen, which is like biking, hiking, anything like cardio, running sort of movement. Anaerobic exercise does not require oxygen, so that would fall under the category of like weightlifting and like high intensity workouts that require more elements, require other things other than oxygen. So essentially, once glycogen breaks down, oxidizes glucose, it then goes into making ATP, which is what your muscles need to contract. So essentially, a lack of glycogen will bring you a lack of glucose, which then will decrease the ATP you're making, which therefore, when the muscle is contracting during exercise, is lessened because you have a deficiency of glycogen. For the second question, it says, I really like to take long walks. Will I still be able to do this with my friends? So essentially, this sort of disease is worse when you do strenuous exercise. So running, jumping, doing all that stuff will cause muscle cramps, muscle weakness, muscle soreness. So you should stay away from those. However, walking, as long as it's on a flat path that's not very hilly, can be okay. I would probably turn that into a short walk rather than a long walk because the muscles, the contraction is what the problem is. So if you are contracting too much or for too long, your body doesn't have enough glycogen to break down into glucose. So yes, you can still go and walk with your friends, but should minimize hills and it should probably be shorter rather than longer. Then, as a result of this deficiency, will I need to get up at night to eat to maintain my blood glucose levels? From this question, what I got at was, when you're sleeping, as long as you're a normal, healthy adult, your blood sugar can regulate itself throughout the night, so that's not necessary. When you have this deficiency, obviously you're low on glucose, but I would say, as long as your glucose is fine before you go to bed, you should not need to get up and eat during the night. As long as it's stable beforehand, it should, your body's insulin production, that should stabilize this throughout the night. So in my opinion, no, you don't need to get up to eat during the night, as long as your glucose is stable before you go to bed. The fourth question, do I need to worry about producing excessive lactate during intense anaerobic exercise? So essentially, lactose is made from the glucose in your blood. So if your glycogen is breaking down and making glucose, if you don't have enough glycogen, you're not making enough glucose. So therefore, you're not going to have an excess in lactate. It's going to be the opposite. You're going to have a deficit in lactate. So no, that should not be something you have to worry about. If your body doesn't have enough glycogen and enough glucose, then it's lactate. So you should not worry about that. Alright, that is case 2. So for case 4, the question reads, a previously healthy 2-month-old female presents with jittery spells several hours after breastfeeding. Her mother reports she has not given the baby anything to eat other than breast milk since birth. The baby has only recently been pooping for more than 2 hours between feedings, and that's when the mother reports these symptoms started. Lab results are consistent with hypoglycemia, which is low blood sugar, and other glucose, otherwise unremarkable. Epinephrine is administered, and there is no increase in blood glucose, but there is an increase in blood lactate, which can relate to the case of just Physical exam reveals the liver edge 4 centimeters below the right costal margin, compression of the right chest and abdomen, confirms hepatology, enlarged liver. blood glucose levels increased after breastfeeding, but she could not maintain blood glucose levels within normal range during the fasting period. Based on the information above, which of the following is most likely diagnosis of this patient? So there are 4 options. Hereditary fructose intolerance, I'm going to say this wrong, galactosemia, glycogen storage disease, which is the inability to use glycogen, and glucose 6-phosphate dehydrogenase deficiency. This should be C right here. This should be D. Anyhow, the correct option out of all of these is the glycogen storage disease, which is the inability to use glycogen, the inability. This is the correct option because the baby has an enlarged liver, low blood sugar levels, and high levels of lactate, even after the epinephrine injection. So those are all symptoms that consist with glycogen storage disease. Some other symptoms you may see with this disease if the baby did not present at this time is delayed growth, bone thinning, and mouth ulcers. So this is why she falls under this glycogen storage category, because she is lined up with these first few symptoms. So the reason these other ones are wrong, starting with hereditary fructose intolerance, it's incorrect because the symptoms of this would include nausea, abdominal pain, gas, vomiting, malabsorption of nutrients, for example, iron, UV1, and fatigue. These are not what she can live at all, so this is why that answer is incorrect. I also believe this disease has something to do with high blood sugar, which is hyperglycemia, so I think that's also why this is incorrect, but that could be. Anyhow, this next one, this option is also incorrect because the common symptom for this one is lost appetite. Stated up here in the information, the baby's being fed every 2 hours, so obviously if she had inappetence, she would not be eating every 2 hours, so that is why this option right here is incorrect. And then for the last option, which is glucose 6-phosphate dehydrogenase deficiency, is incorrect because another symptom of this is fatigue, diarrhea, which is jaundice, and jaundice, which is swelling of the skin and eyes, and a painful abdomen and back. I could be wrong on this somehow, but at least for animals, most of the time when we see jaundice and like liver problems, the liver is enlarged, so that is also a reason why it would not be this, because the liver edge of the physical exam reveals the liver edge 4 centimeters below. So I also believe that is why this option is incorrect, because it's a small liver rather than an enlarged liver. So the correct answer, as stated before, is glycogen storage disease, which is the inability to use glycogen, and hereditary fructose. This one and glucose 6-phosphate dehydrogenase are all incorrect. And then we go here and all the sources. And that's it. I think to recap, answer these questions. And this here is the right answer. Anyhow, I will upload this to YouTube. Thank you.